Hey everyone, welcome back to the Pre-Calculus 20 videos. In this video, we're going to look at Lesson 4 from Chapter 6, which is dealing with rational equations. So a rational equation is an equation containing at least one rational expression. So say, for example, we had x was equal to x minus 3 over 7. So this right-hand side here is a rational expression. We have an equal sign, so therefore we have a rational equation. So working with a radical equation is very similar to working with rational expressions. The only difference here is that there's going to be an equal sign and we're going to be solving for x. But in terms of the adding, subtracting, multiplying, and dividing, it's all going to be very similar work. So we have 5 steps here. So your first step here when you're trying to solve a rational equation is first to factor the denominator if that's possible. So that's, say, if you had an x squared term, break it down to each of the x factors. And then that will help you identify what your non-permissible values are. So then once you've identified those non-permissible values, then you would multiply both sides of the equation by the LCD, which is your lowest common denominator. And so essentially what that step right there will do, this one right here is going to get rid of the fraction. And then we're just going back to, say, Chapter 4, where we're just going to be maybe using factoring, or we're going to be distributing. There's going to be lots of different ways that we've learned in previous chapters and in previous courses in order to solve. So steps 1 to 3 are really just trying to get rid of that fraction and identifying those values that x can't be. Then when you've gotten rid of that fraction, then you want to isolate the variable to one side of the equation. And if need be, you might want to put all of the numbers as well if that would help you out with factoring, or maybe even using the quadratic formula if you had something a little bit grosser. But so start by isolating the variable and see where you can go from there. So then when you've found your answer, then you should always verify, because remember, we could have extraneous roots, or they might not even match, or they might not even fit your non-permissible values that you found in step 2. So check that it works with your non-permissible values and then verify your answers, because you might have those extraneous roots. So now we're going to try some of this out, and we're going to do example number 1 from your notes. So here we're going to solve the following equation, and we're going to list any non-permissible values and verify our answers. So here we have x over 4 minus 7 over x is equal to 3. So the first step there, if you look above, it said to factor each denominator if that's possible. So if you're looking at our denominators here, we have 4 and we have x. Well, those ones there are actually already as simple as they can get. We can't break them down to their factors. So we can just move on to step number 2, where we're listing those non-permissible values. So when we look at our non-permissible values, we only want to worry about the fractions and the denominators that contain a variable. So in our first fraction here, the denominator here is a 4, and that can't change. So we don't need to worry about that 4 because it's always going to stay a 4. The one that we do need to worry about, though, is this x, because x can typically mean anything unless if we restrict it. So we have to look at this x value here. So let's set that equal to 0. So here there's actually no work to do. So here we just have to say that x cannot equal to 0. And then we're actually done our non-permissible values. So then we can move on to the next step. So here we need to identify the lowest common denominator and then multiply each term by that LCD. So step 2 here, we're actually going to start solving. So first we need to identify that LCD, and if you guys remember in the previous video, when we're trying to find our LCD, you basically have to start with one fraction. So look at the denominator. So here, our first one here is 4, and then you're going to move to the next one. Here we have an x term. Well, that wasn't in the previous one, so we need to include an x there. So 4 times x, and then there's no other fractions, so we're actually done there. So our LCD here is 4x. So then what we're going to do now is we're going to multiply each term by this LCD. I'm just going to rewrite our little expression or equation here. So here we're going to multiply by that LCD. So I'm going to multiply by 4x. And make sure you're only multiplying the numerators. Don't multiply the denominators. By multiplying each term by 4x, we are keeping this equation equivalent. It might look a little bit different, but it'll tell us the same thing. So when we multiply, we have x times 4x divided by 4. Well, at this point here, you can actually cancel out some common factors. So here we have a 4 up top. We'll have a 4 on the bottom here. So here we're left with x times x, which is x squared. Then we have subtract 7 over x times 4x. We can cancel those common terms of x and x. So we're left with negative 7 times 4, which is negative 28. Then that's equal to 3 times 4x. Well, there's no fractions, there's no denominator, so there's actually nothing we can cancel out. So that will just simply stay as 12x. So here we have 3 terms. We won't be able to add or subtract any like terms. So because we're going to end up with 3 terms here, what we're going to do is we're going to push everything to one side because we're either going to have to use factoring or the quadratic formula to solve this. So I'm going to move this 12x to the other side. So I'm going to subtract 12x. I'm going to make sure it's in proper standard form, where my highest exponent comes first and then my lowest is last. So we have x squared minus 12x minus 28 is equal to 0. Then, if you notice, let's first start by trying out factoring because it's a lot less work than quadratic formula. So to factor, we're going to be using that product sum method. So that's going to be your first term times your last term, which is negative 28. Then the sum is this middle value here, which is negative 12. So you want to think of 2 numbers that multiply to negative 28 and have a sum of negative 12. So those 2 numbers are negative 14 and positive 2. So remember, it's a negative sum, so that bigger number has to be negative. So negative 14 times 2 will give you negative 28, and then negative 14 plus 2 would give you negative 12. So we're going to use that little shortcut here again. So we're going to draw 2 brackets. And so the first term will be our variable, so that'll be our x value. And then our first number will go in our first bracket. And then our second one, it's positive, so we'll separate with a plus sign. That goes in your second one. And then make sure you still make this equal to 0. One thing I should note, just remember that with this little shortcut method, you can't do this if there's an a value that is not 1. So say if it was 2x squared, you wouldn't be able to use a shortcut. That wouldn't work, okay? So now that we have our 2 factors, now we can set each of them equal to 0 and solve. So here our first one here is x minus 14. So I'm going to get x by itself, so I'm going to add 14 to each side. So here that we have x is equal to 14. Then we can do our second factor, set there is x plus 2, and set that equal to 0. We're going to get x by itself, so we're going to subtract 2 on each side. So we're left with x is equal to negative 2. So what we should do next, before we verify, we should even check that this works with our restrictions. So let's go back up to the top and look at those non-permissible values. So here we said that x cannot equal to 0, and in this case none of those numbers are 0. So far, those 2 answers check out, but we should always still verify it, not only because I asked you in the question, but just in case we have those extraneous roots. So let's verify those solutions. So our first one here will be when x is equal to 14. And you're going to plug it into the original equation. So here we had, it was x over 4. So we're going to have 14 over 4 minus 7 over x. So 7 over 14. And that's equal to 3. So then what we can do next is we want to subtract these two fractions. So first what we have to do is find a common denominator. And maybe what you can even do first is first simplify this to make it a smaller number. You can probably even do this one here as well. So you notice that these two can both be reduced by a factor of 2. These can be reduced by a factor of 7. So 14 divided by 2 is 7. And 4 divided by 2 is 2. Or subtract. 7 divided by 7 is 1. Then 14 divided by 7 is 2. Then we can subtract our fractions. So we have 7 minus 1 is 6. Denominator stays the same. And then 6 divided by 2 is 3. So 3 equals 3. So that means that x is equal to 14 is a solution of that rational equation. So we can do the same for our second factor. So here we had x was equal to negative 2. So every time we see x, we're going to put a negative 2 instead. So we had negative 2 over 4 minus 7 over negative 2. Then if we do that work properly, we should hopefully find that that will equal 3. So once again, just like we did previously, we want to find that common denominator, but maybe first we will reduce. So here we have 2 and 4, and those can both be reduced by a common factor of 2. So negative 2 divided by 2 is negative 1, and 4 divided by 2 is just 2. Then we have 7 over negative 2. That actually can't really be reduced by any number, but we can apply these negatives. So negative times a negative is a positive. So you have positive or plus 7 over 2. That should equal to 3. Then we can add these fractions. We have negative 1 plus 7 will give you 6, and your denominator stays the same. So 6 divided by 2 is 3, and 3 does in fact equal 3. So x is equal to negative 2 is also a solution to that equation. So now that we're done verifying, we have fully answered this question. So if you guys have any questions, make sure to come see me in class or text me on Remind 101. And thank you guys so much for watching.